When we're adding and subtracting rational expressions, we need to have common denominators. As long as our rational expressions already have common denominators, these aren't going to be bad at all. If we're adding, say, 3/5 plus 1/5, our rules of addition tell us we can add the numerators and keep the common denominator, and we simply have 4/5. The same rule applies when we're working with expressions rather than fractions. If we have x over 6 plus 7x over 6, the common denominator is 6. We can add the numerators, keep the common denominator. The numerators are like terms. 1x plus 7x is 8x. And then if possible, we reduce. 8 is 2 times 4x. 6 is 2 times 3. We can reduce. And our final rational expression is 4x over 3. Here's a couple more, a little more complicated, but again, the key thing to note about both of these is that there's a common denominator. X plus 3 and x plus 3, 5b cubed and 5b cubed. With subtraction, we do want to be a little careful, so that we don't forget that we're subtracting. So here we'll have x squared subtract 9 over the common, x plus 3. A common error is to go ahead and multiply the common denominators together. We don't want to do that. It's simply over the common denominator. This one, though, when we look at the numerator after we've combined, we do see we've got a difference of squares, which we know factors. The x squared subtract 9 to x plus 3, x subtract 3 over the x plus 3. We can now reduce this because the x plus 3 and the x plus 3 are common factors. And our final result is simply x subtract 3. So sometimes they reduce after the adding and subtracting, sometimes they don't. Over here again we've got the common denominator, so we can combine the numerators. But we want to be careful because all of this is being subtracted. And so when we do our subtraction up here, we've got a subtract a plus 2 over the common 5b cubed. So when we're subtracting, this subtraction needs to distribute through the parentheses to a subtract 2 over our 5b cubed. The two a's are like terms, and a subtract a is 0. So our final result here is negative 2 over 5b cubed. Okay, so now it gets a little more tricky. If we don't have a common denominator, we need to first decide what is the least common denominator of two rational expressions. So we'll start off just with some numbers here, fractions. A lot of times you can just look at these and recognize it. The 1/2 and 2/3, probably you're looking at that and thinking the common denominator is 3. Excuse me, the common denominator is 6. Because 6 is the smallest number, 2 goes into evenly, and 3 goes into evenly. So if we're going to add these, what we need to do is take each of the two fractions and multiply them by 1 in such a way that after we do the multiplying, we have the common denominator of 6. So the 1/2, to turn the denominator of 2 into a denominator of 6, I'd need to multiply the 2 by 3. And I can do that as long as I multiply the numerator by 3 also. What I have then is 3/6, which is equivalent to 1/2. It's just not reduced. And then the 2/3, I can multiply by 2 over 2, giving me 4/6, which is equivalent to 2/3, but again, is not a reduced fraction. We're disguising our fractions in order to get the common denominators. So one thing to bear in mind, these problems tend to look a little worse before they start looking better. So our numbers got bigger, but we now have the common denominator, and we can add the numerator, and that's going to give us 3 plus 4 over 6, or simply 7/6 for our final result. Okay, this one's a little trickier. It's not easy to spot just looking at it what the least common denominator is. So what we can do is take the denominators and factor them down. 24 is, let's see, 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. So 2 times 2 times 2 is 8, times 3 is 24. And so this one, the denominator is 2 to the third power times 3. And then the 36, 36 is 2 times 18, 18 is 2 times 9, and 9 is 3 times 3. So let's see, this gives me 9 times 4 is 36. Yeah, checks out. So I've got 2 squared times 3 squared. So the least common denominator will be all the different factors. So looking at our two denominators, I've got bases of 2 and bases of 3. So I'll need 2's and I'll need 3's. And I'll need as many 2's as the most number that show up in any one denominator. So there were 3 2's in this denominator and 2 2's in this denominator. So I'm going to need 3 2's in my least common denominator. There is 1 3 here and 2 3's here, so I'm going to need 2 3's. So basically, I'm taking the one with the biggest exponent. That way it covers both of these. What number is this anyway? 2 cubed is 8, 3 squared is 9, 8 times 9 is 72. 72 is the smallest number 24 goes into, and 36 also goes into. So all of that was just to find the least common denominator. Then once I had the least common denominator, I need to rewrite my two original fractions so that they have that common denominator. So what I like to do is think about what's missing. My original problem here, I had 1 over 24. So the 24 contains the 3 2's and the 1 3. So in order to have the 2 cubed times 3 squared, all that's missing from the 24 is a 3. So I need to multiply it by 3 over 3. And then the 5 over 36, the 36 contained the 2 squared and the 3 squared. My common denominator is 2 cubed and 3 squared, so it's just missing a 2. So I put in the missing factors. Again, I'm unreducing my fractions, so things look a little uglier here at the moment as I get those unreduced fractions. But then there is something that has a common denominator. 3 over 72 plus 10 over 72. And then I can add my numerators for 13 over 72. So when you're finding the least common denominator, factor each denominator first. The LCD is the product of each of the different factors, so all those different bases, raised to the highest number of times, so the biggest exponent, it appears in any one denominator. Okay, I guess I'm repeating myself there. So again, factor denominators, product of each of the different factors or bases, raised to the highest number of times it appears in any one denominator. So these two, we're just going to look for the LCD. We're not going to actually do the addition. So looking at the 20 and the 15, I'm just going to break this down a little bit further. 20 is 2 times 10, 10 is 2 times 5, so this would be 2 squared times 5, a squared, b cubed. And then the 9 is 9 over 15, breaks down to 3 times 5, a to the 1 and b to the 4th. So then my LCD, get a little more room here, all the different factors. So I've got 2's, I've got 3's, I've got 5's, just looking at the coefficients. So I've got 2, the biggest exponent at any 2 is a 2. I've got a 3 and only the 1 3. I've got a 5 once here and once here. So the 5 never shows up with a bigger exponent than an exponent of 1. So I only need 5 to the 1, or just a plain 5 in the LCD. And then I've got bases of a and b. I've got an a to the power of 2 here, a to the power of 1 here, so I need a to the power of 2, going with the biggest exponent. b cubed, b to the fourth. I need the b to the fourth. So this would be my least common denominator. Sometimes it's convenient to go ahead and multiply the coefficients together. Sometimes it's easier just to go ahead and leave them in the factored form. So either way is fine. Let's see, multiplying these together, looks like it'd probably be 60. A squared b to the fourth. Or again, you can leave it in the factored form. This next one's kind of tricky. Our two denominators are x subtract 5 and x plus 5. And the first thought, I think, to most students is, well, the least common denominator is going to have the x and 5. We've got to be careful here is think a minute again about the difference between terms and factors. Factors are joined by multiplication. Terms are separated from each other by addition or subtraction. So this x subtract 5 contains two terms, x and 5. And the x plus 5 contains two terms, x and the 5. But those are terms, not factors. Our least common denominator here is going to be x subtract 5, x plus 5. It's going to be the product of the two separate denominators because those two denominators have no factors in common. They've got some pieces of terms that are in common, but no factors in common, so we need both of these. Careful there, make that look a little bit more like a 5. The x subtract 5 and the x plus 5. Okay, a couple more, and then we'll take a little break and actually start adding some of these together. Again, though, here we're just looking at the different factors. So if we're going to look at the different factors, we're going to have to factor sometimes. So taking the x plus 4, not really worrying about what's in the numerator. My first rational expression here has a denominator of x squared subtract 36, which I think you should recognize as being a difference of squares. So this would factor to x plus 6, x subtract 6. And then my second rational expression is going to factor. And it's actually a perfect square. This one's going to be x plus 6, x plus 6, or x plus 6 squared. So when we find the least common denominator on this one, we'll need the x subtract 6. So that's a factor. And then we've got an x plus 6 here and showing up twice here. So we'll need x plus 6 squared, or x plus 6, x plus 6, as our least common denominator. So sometimes I like to write it in the compact form. Sometimes I find it easier to work with these if I go ahead and expand them to the x plus 6, x plus 6. Either one's fine. You can decide which way you prefer after you've done some more of the problems. Okay, so my last example here, a little bit tricky just with the 2 subtract 2x. I think we're going to have to tweak some signs around a little bit on this one. The x squared subtract 1 is a difference of squares. So this one is going to factor to x plus 1, x subtract 1. And then looking at the second, oops, that's not a 6, that's a 3, sorry. My first thought is to take out the 2, leaving behind a 1 subtract x, which is almost but not quite the same as the x subtract 1. So I'm going to back up here a second. This was kind of messy to begin with. Let's start over. Instead of factoring out a 2, I'm going to factor out a negative 2. If the factors are almost matching, but not quite, they're off by a sign, try taking out a negative and seeing what's left. If I take a negative 2 out, negative 2 times the negative 1 gives me the positive 2 I had here to begin with. And negative 2 times the plus x would give me the negative 2x that I had here to begin with. So if I rewrite this, I have negative 2. Negative 1 plus x is equivalent to x plus negative 1, which is x subtract 1. Then I've got this common factor. We are really hoping to have some common factors before we find our least common denominator. If there aren't any common factors, these least common denominators can get very, very large, which makes things very cumbersome when it comes to adding. So we are hoping that there'll be some common factors showing up keep our denominator from getting too large. So our LCD on this one, what do we have? We've got the -2. I don't know why my pen does that sometimes. There we go, -2. We had the x plus 1 that was in the first expression. And then we have x subtract 1 in the first expression, another x subtract 1 in the second expression. But since the x subtract 1 does not show up more than one time in either expression, for a common denominator, it will simply be a single x subtract 1. And there's our LCD.